So yeah, so these are the some of the images we had with respect to rescaling of the data images. And if I go down, yeah, you can see we just converted it into the 100 encoding, so that yeah, you can see one is for pizza, zero is for a stick, like that. So similarly, yeah, creating some of the model with some of the baseline models. So this is very simple CNN architecture, I can say. So we can also learn maybe the predefined some of the pre-trained models in the CNN. That is also very helpful while doing with the transfer learning. I will explain you that maybe a little later, but as for now, we can see the some baseline model with the convolutional neural networks. We can also introduce the different concepts like activation functions today. So we are already seen we have using so many activation functions with respect to the RNN and also the LSTM GRU along with the CNN. So how does this activation functions are helpful? I always saying something called as a firing results, right? So where do we use and why to use? How does this going to be helpful? Let's go and check out this. So why do we use activation functions means the major agenda for to use activation function. If suppose you have a nonlinear transformation, if suppose you have a some linear kind of the transformation, that is fine. Bunch of the points are here, bunch of the points are here. You're just drawing the hyperplane. That is fine. This is excellent, I can say. But what will happen if you have a nonlinear transformation? In your classical ML, you have shown some of the different techniques to do by using the nonlinear transformation like this. So you have a points on this region, you have points on this region, you have points on this region. So at the point of in this region, you may not be separated. And likewise, you can also see some of the data points looks like this. Some of the data points may not be separated, even if you draw any hyperplane also. So for this, what you have to do? For this, you had to do nothing to do anything. So you can separate by this, you can separate by this, you can separate by this. That does not matter. It may not be works out at the time. So at that time, what you had to do, you had to tune further. You had to tune further to compute results in terms of much better for the activation functions. So whoever having the non-linear, or you can say non-linear transformation related thing, we just added some approximation to addition value to get some kind of the firing nature, to you can say to get some kind of the complexity relationship between the variables. This is also allowed in the neural network. So that is a major reason. And even though we are going to be used in these functions called activation functions with respect to the weights, so we already learned backpropagation algorithm where we implemented with respect to weights with whatever the nodes we had, corresponding the nodes we had, right? Suppose the w1 weight related to the x1 input along with w2 weight corresponding to the x2 input. Similarly, wn corresponding to the xn input. So at this fashion, I can say we are going to be computed each and every node with respect to the activation function to attach some weights on this. So it's possible to attach some of the weights with respect to activation function to the weights that will be additional value or additional weighting results to your modeling. This will be multiplicable, obviously. This is going to be multiplicative to your activation function, which activation functions are going to be used at the time. Even though we have also seen in the logistic regression, while we encountered to squashing or while we encountered with the sigmoid function to use for smoothing curve, right? This is some logistic function or logistic curve. At the time we just know the smoothing this curve, we just use the sigmoid function at the time. Sigmoid function at the time, that is 1 by 1 plus e to the power of minus x. So this is also one of the activation function in the neural networks, I can say. So this came from the neural networks only, but at the time we use it from the classical ML. So that's the reason I have not gone through the explanation of the sigmoid function. So in this notebook, we're going to see the how does the sigmoid function is going to be helpful, and what are the different advantages with the sigmoid function. So yeah, sigmoid function will be lies between the zeros and one. It's going to be give as a probabilistic interpretation between the your weights and also the input results. If suppose we already seen, I think, in the back propagation algorithm, if your activation functions may not be differentiable, if activation functions may not be differentiable, you may not be considered into the back propagation algorithm, because we are using as a chain rule at the time, right? Because we are using as a chain rule plus memorization. But since you are using the chain rule, so at that time you may required as a differentiation. At the time you required as a differentiation, it must be do some kind of the differentiable with any regarding activation function, let's take. So in this case, sigmoid function in this case, at the time of zero, it may not be differentiable at that much. So some of the cases it will be used for classification perspective only, not for the regression that much. But you will be encounter some of the cases, maybe the positive or the negative values, because of the differentiation may not be happened for the zero kind of value. And some smoothing curve with respect to whatever the sigmoid function we had, that is a tan h. Tan h is one of the good activation function as per now, but somehow the disadvantages with respect to the tan h also. So this is how it's going to be looks like. It lies between -1 to +1. So whenever you encounter to analyze this function, it is also very similar to the logistic curve, but it lies between the 0 to 1, but it lies between the -1 to 1. The output results may be satisfied with your negative results also. So at the time of middle, I can say, I mean, in the time of the middle differentiation with respect to the logistic curve also may not be differentiable with the tan h. According to the, it is also works well with classification only, but not for the regression perspective most of the times. So even though something smoother curve with respect to the tan h, with respect to the tan h curve, tan h function, activation function, it's also light between that, but still it may not be figured out with respect to the differentiable with the zeroth kind of the value. If possible, if you have a value d of 0 by dx, it's infinity obviously at the time of you differentiate with respect to zero kind of the value. And also it may not be controlled any results at the time of you reach it as a zero value. And some of the cases what will happen, yeah, this is the one of the activation function. Some of the cases what will happen,